Okay, if you turn to page 33, we're going to go over what a scatter plot is and what a line of fit is. Now, a scatter plot is a graph used to show the correlation between paired data. Correlation means relationship between the data or the trend, how the data relates. So let's look at my first graph. So for my first graph, I say this is the minutes you spend studying. So maybe somebody who doesn't study at all gets a 50 on the test. This is the test score. But somebody who studies for 2.5 hours gets 100 on the test. Now, obviously, that is not always true. But in general, there is a correlation that the more you study, the better you do on a test. Now, what a line of fit does is you take the high point of the data and the low point of the data, you connect the two, and that line shows the trend of the data. Now, this line is positively sloping. So we say this has a positive correlation. So the correlation between these two data points, how long you study and your test score, is positive. Now, let's compare that to suppose now instead of the x-axis representing how long you study, it's hours you spend a day on video games. So someone who doesn't do any video games and is very studious, let's just pretend they get 100. Then we get to somebody who spends 5 hours a day, they don't do as well. And somebody who spends the entire day playing video games so they don't even take the test gets a very low score. So again, if we were to do a line of fit, we take the low point and the high point of the data, we connect them for our line of fit, and that shows this is a negative correlation. Okay, again, do I really think that the more you spend time on video games, the lower your grade? I think sometimes there is a correlation, okay? Although I know there's some people who can do just fine and still play video games. Now, the last one I want to show you is, we're going to say, again, this is test scores. And my other piece of data here is going to be your height. Now, this may not surprise you that the data looks like this. Now, does it appear to have any correlation? Could I easily draw a line somewhere through this? I mean, I could follow these data points, that would be positive. I could follow these data points, that would be negative. The fact that I don't know where to draw the line is an indication that there's no correlation. So, when we talk about scatter plots and we talk about correlation, this is back on page 33, if y tends to increase as x increases, so the data move together, the paired data are said to have a positive correlation. When x increases, y increases, that's a positive correlation and a positive slope for a line of fit. If y tends to decrease as x increases, that's a negative correlation and a negative slope. And if they have no apparent relationship, we say there's no correlation. Now let's look at the two graphs on the bottom. These are scatter plots. We don't know what x stands for. We don't know what y stands for. But this is clearly a negative correlation. As x increases, y decreases. This has no correlation because I could draw this positive and I could draw this negative. Okay? So now let's look at page 34. And I'm going to have you guys just do this C. I want you to make a scatter plot of this data. You're going to start out by labeling this axis. You're going to count by ones, and labeling this, and you count by ones. And you're going to plot all of this data. And when you're done, stop the video now and start it up when you're done. Okay, now this is what your data should look like. Let's wait till that focuses in. Okay, So clearly, although this is not a clear picture, this is positive correlation, because when you plotted this data, it ended up being a positive correlation. As X increased, Y increased. Now, I'm going to show you, even though this is a little fuzzy, and I apologize for that, how to draw your line of fit. Easiest way to draw the line of fit. Now, the line of fit is the line drawn through the data of the scatter plot to show the trend of the data. And the most efficient way to do this is I start with the lowest data point and the highest data point. And I just connect the two. Now, is that always going to give you the best line? No. But is it the most efficient way? Yes. And do you think I'm following the trend of the data? And I would say yes. Now, some people might argue, okay, you drew a line, but I don't think that's the best line. The way I see the data, I think your line should look like this. And they could be right. And those are two different lines with two different slopes. But they both are positively sloping lines, and they both do show the trend of the data. Now, I'm going to say this, that when we actually use scatter plots and lines of fit, this is something we do on a graphing calculator or something we do on a computer. In real life, these are used a lot in marketing, but these are used on a computer. Nobody's going to do this manually. The only reason we're learning how to do it manually is so you understand the concept. But I don't want people to stress out too much where you draw the line, because now if I drew the line this way and you drew the line that way, we both can be correct, even though we're different. We just interpreted it where the line should go a little differently. So this is not an exact science unless you use a computer. But this line is called the line of fit. So I want to go over the process of using a line of fit to model the data. So step one is you make a scatter plot of the data, which you guys now know how to do. You decide whether the data can be modeled by a line. So is there a correlation, be it negative or positive? If there is, you draw a line that appears to follow the data closely. Okay, that's the most important thing. And then once you've drawn your line, you come up with an equation of that line. But the important thing is you must use 2 points that are on that line. They don't necessarily have to be data points, but they must be on the line. And also here, I would never use, let's say, this point for my equation because it's not on the line. So if I was going to use this line here, then I might use that data point. But if I was using this line, I wouldn't use that data point because it's not on the line. So the important thing is always choose a point that's on the line. Now, let's turn to page 35. On page 35, you were given a bunch of data here, and I drew the line for you. Okay? Now, notice if I was to come up with an equation for this particular line, I would choose this. I make a big circle showing that point and this point because I have to pick 2 points on the line. Okay? So when you do choose 2 points, you do a big circle to show me which points you're choosing. Now, if I had followed my own advice and connected the lowest point with the highest point, I would have chosen this line instead. Okay? They're both very similar, right? But if I had chosen the second line I drew, then I could have used this data point and this data point. So I actually think the easiest thing to do is to pick the lowest data point and the highest data point as long as you feel it's following the data. But since that isn't what I did, we're going to use this point, which I said was 747. And we're going to use this point, which is 328. So how would we describe this correlation? This correlation is positive. So once you have decided where to draw your line of fit, then you pick 2 points on the line and you come up with an equation. Well, if I give you 2 points, how do you come up with an equation? Well, you start out by finding the slope. So you will see I found the slope by doing 47 minus 28 over 7 minus 3. So my slope is 19 over 4. And my equation would be y minus 47 equals 19/4 times x minus 7. So I came up with a line of fit. Now sometimes I will tell you put that line of fit into slope-intercept form. And if I don't tell you, you can leave it in point-slope form. Now, the next question says, use your equation to determine the value of y when x is 13. Now, notice on my graph, x only goes up to 10, okay? So if I look at my graph and I brought this out here and I went all the way up here and tried to estimate where it would be, I would guess it would be around in the 70s. Right? But it's not on the graph. So the way I'm going to figure out a value is I'm going to let x equal 13 in my equation. So instead of writing x, I write 13. 13 minus 7 is 6. And when I do 19/4 times 6, I get 57/2, which is 28.5. And when I add 47 to 28.5, I get 75.5. And that kind of matches what I expected, because we know the line would continue and it would kind of go over here, and it looks like it would be up in the 70s. Okay? Now, let's turn to page 37. Okay? So turn to page 37, and we're going to do example 4 together. Okay, so I want everybody to do this on their own. I've labeled the points for you, so stop this video, graph all these points. So in other words, I'm going to graph 1, 5, etc. Graph all the points and start the video back up when you're done. Okay. So here I graphed all my points. This is my low point. This is my high point. I draw a line through my low and my high, right? So I chose the point 1, okay. How did I get 1, 5? Let's not look at this. Let's not look at what I did. Let's look at what we should do. So, oh, if this is 1, 5, that's how I got it. And this is 2, 8, 3, 10, 4, 9, 4.5, 12, 6, 14, 8, 19. So I'm going to circle this and this. Okay, that's how I got 8, 19, and 1, 5. Okay, so with 8, 19, and 1, 5, I have 2 points. And where did I get those 2 points? I connected the low point and the high point. The low point was 1, 5, the high point 8, 19. So I say 1, 5, 8, 19. What do I do now that I have 2 points? Now that I have 2 points, I'm going to find the slope. So I do 19 minus 5 over 8 minus 1, and I get 14 over 7, which is 2. So now I make this x sub 1, y sub 1. I say y minus 5 equals 2 times x minus 1. I'm going to change this to slope-intercept form because this one's going to be easy. And I end up with y equals 2x plus 3. Now I want you to notice, if I look up, I got a y-intercept of 3. If you look up here, it does look like my y-intercept should be 3. Okay, so now my line of fit is y equals 2x plus 3. How did I get that? The low point of the data, the high point of the data. I connect them, form a line. Take my low point, my high point. I have 2 points. Find the slope. Then use point-slope form. Change it to slope-intercept. Okay? Now, what we're going to learn now is we're going to learn two important words. Linear interpolation and linear extrapolation. Interpolation is estimating between 2 known values to graph and estimate an answer. Extrapolation is estimating outside of the known values using an equation. The next video will go over that.